Talk here for today. So next up we have David Early. Dave works for Red Hat as a graphics developer. He develops and debugs many enterprise graphics issues for Red Hat customers. He was one of the principal authors of the kernel mode setting stack and has contributed a lot of code to all major GPU drivers and the Mesa 3D stack, some of which we'll hear about today. Please welcome Dave.
So my talk is basically teaching the X server new tricks. I surprisingly just realized there's no pictures of dogs in it, which would have been apt, but yeah, well. But yeah, it's basically what I've been working on for the last 2-3 years, probably on and off for Red Hat. It's sort of like features that we needed in the X server that just weren't happening because there wasn't anyone else working on it. So I started working on it a couple of years back, and this is sort of, I'll go through a bit of like the history. I'll go through then what we've sort of done that's coming out now, what you'll see in like Fedora 18, RHEL 7 type timeframes from Red Hat. And then what I'm going to say, what the future could be, I would say would be my plan for the future if I actually have time to do it. But it's currently sort of open on what I actually do. But before that, I'll just have a small bit of math to explain why I might not be understandable today. So that, plus those things, is this. So yeah, so I said I've been working in X Windows kernel graphics drivers stuff for 7 or 8 years now. I've been in Red Hat for 5.5 years. I sort of became the kernel graphics maintainer by accident and sort of laid on from there. So yeah, I'll just take you through sort of a brief history of. Oh, actually, before I do the history, I'll just bring you through some of the terms you may come across in my talk and go, what the hell is he talking about? Simple, quick run over. Pix maps are pretty much bitmaps, square things with pixels in them. GC is a graphics context. It's an X window thing. It sort of contains the information about doing a rendering operation. So it's like if a line has stipply bits or the foreground color of your text or the background color. Damage is a concept Keith sort of covered as well. It's where you're rendering something and something gets rendered over something, that's the damaged area. Windows in X Windows are the actual window, so they're sort of built on top of Pix maps. Pictures are a thing, pictures and render are sort of interrelated. Render is a rendering protocol that was added after the core protocol by Keith. It's like makes compositing sort of composited render work a lot better. And then a compositor is something like GNOME Shell or KWin, stuff like that. But these are the terms I'm going to sort of use randomly, and hopefully you can follow along. They're not that too. But I'll start off with a brief history of time in the X server, or at least how it is with respect to setting up outputs and stuff. So way back in the early dawn of time, this is how X worked. There was a single protocol screen, the little :0 you get to see when you are confused by something. A GPU driver was sitting inside the X server, and then you had a GPU, and then you had a screen. So hopefully the colors came out. Yep, color came out better up there than they have done. So the way that little box on the that side, on this side is represented is the internals of the box are what GPU is actually rendering the screen, and the external frame of the box is what GPU is displaying that screen, or that piece of the screen. So back at the dawn of classic X, that's how it worked. There was one GPU, and the driver was responsible for rendering it, and the GPU would display it, and it was all very simple. But like everything, it didn't stay simple for long. So the next thing that sort of, probably was still there at the dawn of time was multiple protocol screens. So this was sort of like a thing that people would probably still use today, where not so much this, but you will have 2 GPUs. So, I've got 2 monitors, so I obviously need 2 graphics cards to drive them, and they're completely separate desktops, as in I'll be running you'll see there's a little gap between the 2 things. There's no window movement between them. There's nothing. They're just running as 2 completely separate entities. You've got your, I was going to say GNOME, but when you were running this, you were probably running FVWM or something useful. So yeah, it works, but it was like, you couldn't move windows between it. Bit of a drawback, and you had multiple graphics cards. So yeah, 1 per monitor, kind of not scaly. This is a thing called Zapod mode. We sort of put this name on it just to give it a name years after everyone used it. But
this name existed in 1989.
Did it Zapod mode? Yeah, we started. It started getting more resurgence lately, I think, since we started using it as options. This is the case. You have a single GPU with multiple monitors connected. but you have two GPU copies of the GPU driver effectively. So you've got a protocol screen with a copy of the GPU driver for :00, and you have a protocol screen with the GPU driver for :01. And if you look at the picture again, you'll see the one GPU and that driver is doing this one, and GPU and that driver are doing that one, and they don't meet. There's no crossover. The guys, you can't move windows, you can't talk between them. So we go on another little while, and we come to the great wonder that is known as Xenorama. Yes. Xenorama was the pinnacle of everything. Basically, Xenorama realized, oh, people want to move windows between these two disparate heads. Now, how can I do that? Could I do it sensibly? No, that wouldn't be right. I'll go and just wrap the two things at the really highest level. So it introduces a whole new fake protocol screen level at the top. And then the internal things are just the same as they were in the previous one. And then the GPU rendering and displaying are just the same as they're in the previous one. The way it generally works with Xenorama is the protocol comes in and it gets sent to each screen separately. So everything gets rendered by each screen. Every window, there's two copies of every object. So every window, there's two copies of all of its information, one on each screen. There's two copies of all the PixMap information, one on each internal screen, so on. So every GC, everything, there's two copies of everything. There's also a very special relationship between the protocol screen 0 and the internal protocol screen 0. Trying to separate them, it uses the object identifiers from the internal protocol screen for all of the things in the fake protocol screen. So you end up with this, you can't make that screen go away. So hot plug, not a hope, because it's nearly impossible to capture all the places you put all these IDs. But yeah, this was handy because it would let you at least move windows between your two GPUs. You can do this with a single GPU, but it was kind of silly. There are people who... Yeah, we did this with a single GPU for a while, but then, thankfully, in more recent times, we got Randor 1.2, which was the protocol to do, saneness. So you had a protocol screen, a GPU driver, a GPU, but you had two monitors connected, all being rendered by the one driver, and the GPU was displaying both of them. Hey, it was like sanity. But the problem with this sanity was people started making hardware that didn't quite fit into this. So what came along to change this? What's made my life annoyingly hell? Well, one of the first things that came up a few years ago was, I have one in a bag. Yeah, I'm sure you'll have seen them around if I can find it. No, probably don't have one in my bag. But yeah, you basically have USB dongles. You've seen a little things that come from DisplayLink. There's also some from another company called SMSC, but they're basically a little USB to HDMI dongle or USB, VGA, DVI, pretty much do everything. These things were starting to become more and more common, and you started seeing them a lot in docking stations from major laptop vendors, sadly. So they had USB docking stations with a video thing on the dock. You also got to see a lot of multi-seat pluggable little boxes. So they'd have a keyboard, two USB ports, an Ethernet port, a sound port, and a video port on a little box, and you could multi-seat by just plugging that into your back of your machine, and you should get a whole new multi-seat. So these things were sort of coming out of the roadwork. I'm going to say they're new technologies for Linux. For Windows, these were sort of, oh yeah, we had to support that. The other thing that's come along a lot is multiple GPU laptops. So hands up if anyone's got a laptop with like Optimus or Crappiness or whatever ATI call it. So yeah, the problem there being multiple GPU laptops come in every imaginable way you could think to mess up having two GPUs. So you'll have cases where you'll have an Intel graphics integrated chip on your CPU, and that's connected to the panel. And then your NVIDIA GPU is connected to the DisplayPort connector. And maybe it's connected to the other DisplayPort connector, and sometimes it's connected to the VGA connector. Sometimes it's not connected to anything. It's like, they literally went, how much can we mess this up? I have one laptop where they have connected the DDC lines, for the monitor detection, to both chips, but not the data lines. So the Intel card will say, there's a monitor there, but can't actually drive it. And the NVIDIA card will go, hey, there's a monitor. And occasionally both of them will try and do DDC detection at the same time and go, oh, there's no monitor there. And your monitor will disappear for a little while. So in terms of how not to design hardware, all of this. So yeah, these things have sort of come along and made, a few years ago, my boss was like, well, what do you want to do next? KMS is sort of done. We got just maintenance mode. And I said, well, I'll try and fix this. Silly me. Next time someone asks you that question, Yeah, do something else. So what happened? How did I do it? Well, it eventually became Render 1.4. It's gone out. It's actually released now. It's in the Xserver 113.1, I think, was probably the best one that's been out. But yeah, there's fixes going in. Keith is reviewing the fixes any day now. But yeah, so Render 1.4 was my solution. So what did I actually, we do with Render 1.4? So the first problem was USB hot plug. How do we deal with that? Well, so I decided we'll make the Xserver load multiple graphics drivers in one protocol screen. So instead of doing this whole fake protocol screen with multiple internal protocol screens, we decided, okay, I'll just make it load the graphics driver as a slave of the main graphics driver. And it'll be able to just do certain functions that slave does. In this case, the slave is going to be a USB hot plug device. You plug it in, it appears. So first of all, I had to add hot plug support to the Xserver because it didn't have any. I had to add UDEV support to the Xserver because it didn't have any. And getting all that working, because it was doing its own PCI bus probing and doing all that stuff itself. So getting it to use the standard kernel interfaces, because that was the only way that you could get a USB device to work with it as opposed to PCI devices, because the server understood PCI and everything else. So it was like I needed a new thing that could do PCI and everything else at the same time. So yeah, essentially what happens in this case is you plug it in. The GPU driver, the renderer, so the Intel guy is doing the renderer. So the main GPU in your laptop is doing the rendering of the whole screen. It's only displaying one piece of it, but it's rendering the rest as well. So it's doing a very wide frame buffer and rendering it all. We then take the piece that the Intel driver has rendered, the extra piece, and the Intel graphics card copies that piece to a shared buffer that the USB device can access. And then the USB device literally just maps that in the kernel and does its compression and magic stuff that the kernel driver does and sends it out across the USB link. And you get the displaying down here stuff that was rendered by the Intel but drawn by the USB GPU. So, yeah, it has to copy because Intel has a tiling. You can't scan out directly from the tiled thing, and coherency is a mess. So, yeah, you would have to copy. Yes, you do. No, you never made it work. Yeah. I've seen the detiling in software code retried 4 times, and it changes every GPU. So the second case that came up was that we fixed with Render 1.4 is GPU offloading. So this was, okay, I've got a secondary graphics chip. What can I do with it? It's sitting there, currently it's sitting there burning all your battery. But if I wanted to actually use it for something other than heating my knees, what would I do? So I said, well, the first thing I could probably do is at least let you draw something with it. I can get your OpenGL applications, your DRI applications, to be drawn with that chip, but displayed on the current screen. So you can play games, or play games actually. I'm trying to think what else I could do. Run Gears, which is pretty much actually all I've ever done with it. But run a lot of Gears. Yeah, Gears and I think Open Arena once. But yeah, so this is the idea. We'll do that. So in this case you have the same thing again. You've got a slave GPU driver that's loaded into the server after the main GPU driver. You've got the main GPU rendering and displaying the main screen, but then the secondary GPU is taking one of those, a window in that screen is being rendered by the secondary GPU actually. It kind of abuses DRI2 a bit. It works on the fact that with DRI2 you have an off-screen rendering and the second GPU renders into the off-screen buffer. That off-screen buffer is then shared with the primary GPU, and then when you're doing the back-to-front copy, there's a special engine on the secondary GPU to do that copy. And then when you need a compositor running for this to work, because then the compositor takes the shared buffer and puts it on the screen. If you don't have a compositor, you need the secondary GPU to be able to write directly to the front buffer, which it could work, but not really, because again, tiling screws you.
You got this Express, and it's not clear whether even chipset that you do.
Yeah, writing from PCI Express. So yeah, it's a messy thing, but yeah, the way most of the Optimus GPUs and AMD GPUs have a special engine that's specifically designed to move stuff while the 3D engine is rendering other stuff. So it's asynchronously done. We're starting to take advantage of that now. We know how they work on the NVIDIA chips and the AMD chips, so we're hopefully going to start getting that out. The other area that's sort of missing and I've sort of glossed over is how you deal with synchronization between GPUs. Currently it's like GPU, CPU, GPU, so the synchronization is always done by the CPU having to block and wait or stopping other things from happening. There is work being done by one of the guys in Canonical that's to do proper synchronization, inter-GPU synchronization, and he also is trying to expand it to like video for Linux devices and webcams, things like that. So there is work ongoing on this. The problem with it is it's not just a DRM problem. It's not just my piece of the kernel. He's got a lot of code that's wants to go into driver's base. He's got a bunch of mutex changes that he wants to get, and trying to get someone to review mutex changes is like, hey, trying to find, it's easier just to push them and then get flamed. We have someone looking, but yeah, it makes a lot of sense, Linus. It does, but it's like, yeah, the only way to make this work is this crazy reservation system. Otherwise, deadlock time. So it's a whole talk on its own, and because I'm not actually the one doing the design work on it, I decided I wouldn't take the guys. So one other feature that I've added, let's just say, regrettably added. I didn't really want to do this, but time was not on my side, so I decided, well, I better do something that at least lets things work. So a lot of those crappy 2 GPU laptops, oh, I've got a DVI, or my DisplayPort's only connected to the NVIDIA chip, and I've only got the Intel chip on my LVDS panel. Oh, I go to a conference and I plug in a conference with more modern equipment. I plug in a DVI connector, a HDMI connector, or TV, and I can't see anything. Nothing comes up on screen. How does everyone else solve this? So what Windows does when it detects you plugged in something externally, it swaps over the graphics cards. It literally stops rendering on one graphics card and starts rendering everything on the other graphics card. And if the Intel is in and connected to the LVDS, it reverses things and sends the data from the second graphics card to the one that's connected to the panel to draw the panel. So it sort of swaps everything around. In Windows, this goes blink, blink, chunk, chunk, machine goes crazy. In Mac OS X, you can't even see it. It's seriously crazy how good they've done it. Yeah, no, well, they've hardware help. The hardware help is only the last bit. You can do it without the hardware help, but the hardware help, they've gone just to make it perfect, but you don't need the hardware really to do that. So in Linux, I wanted to do GPU switching, and I'll come to that in a bit, but it's a bigger problem. It involves a lot more work in compositors and stuff. So I went and realized I could do this thing. I named it reverse prime, which was, it's backwards, because literally you're now running two GPUs, burning as much power as you can just to display something on your HDMI. But it does actually work. When the synchronization stuff comes along, it'll work without tearing. At the moment it tears. But at least when you plug something into your laptop, it now displays. But how this works, quite annoyingly, is, yes, you have your main GPU driver, slave GPU driver, same again, GPU, secondary GPU. But unfortunately, most of the video cards, like the discrete video cards, AMD, NVIDIA chips, cannot scan out from main memory. They don't like scanning out from the GTT map main memory, which is sensible. It's probably a lot of data over your PCI Express bus just to scan it. But they don't like doing it. They can probably do it, but the driver writers have said, please don't try this.
They can.
Yeah, no, it can be made work. It's just, it's not stable. So it's messy. So this guy, in this case, again, we have the main driver rendering the whole screen. Again, though, it's copying it to an intermediate shared buffer, but unlike the USB case, we get another copy. So the GPU, the second GPU then has to copy it from this intermediate shared buffer into its video RAM, so that then it can display it. I shoved this into Fedora 18, I think about 2 days before it released, so it's probably in updates testing or something like that at the moment. It's on its way. Yeah, basically this was just a, gotta have some solution that at least lets people use these laptops in public, because otherwise.
The copies are done by DMA?
Yeah, they're all done by GPUs. Yeah, so it's not, they're not slow. It's just the synchronization is missing now, so there's a bit of tearing. But when the synchronization, I actually have tested it. Hey, I got a pre-release of the synchronization and ran on one laptop, and it seemed to work fine. All the tearing went to.
Damage to limit the copies, or you like them?
Yeah, no damage is used. So it's only damaged areas that get updated. So yeah. But unfortunately, it's damaged areas that get updated, which is something I hadn't mentioned. So yeah, in this and the USB case, unfortunately, when you page flip your compositor, which you do if there's something big getting rendered, it damages the whole screen. So you got to extend the whole screen every time. Or if you did what I did and make a mistake in the driver, which everything damaged the whole screen. So everything goes really, really slow. So what's next? Where do I go now? Why was this? So the flying cars future, if it ever comes, I don't know. So GPU switching, simple picture of it. Yeah. So pre-switch. Before the switch, you have a GPU driver and a slave GPU driver, the same thing. You've got a GPU rendering the screen and it's displaying the screen. And you do a GPU switch, and it's basically the other way around. What the GPU that was the slave is now the primary, and it's now rendering the screen and displaying the screen. Again, that's the simplest form. The multiple GPU laptops, they come in two forms. There's ones that have a hardware switch that you can switch the panel between the two chips, and they have ones that don't have a hardware switch, where you have to copy the screen content if you're rendering with the second chip to the first chip. So you'll find generally older Windows laptops will have a switch, and they'll have gotten rid of it, or at least they'll have the switch, but you won't be able to use it from the operating system. It's just a BIOS only feature. And so Windows Vista needed the switch, Windows 7 doesn't need a switch, and Windows 8 doesn't need a switch. All the Apple Macs have the switch, and their switch is hardware and very well sneaky designed, very well done. But it kind of makes it hard for us because Windows just made one decision, macOS made another decision. Now we have an operating system that needs to run on both. Not really sure what the best way, but yeah, so we'll probably use the switch if we can find one, and not if we can't. So again, you sometimes in this case you'll end up with the actual display being connected to this secondary GPU and then a copy happening. But this is essential. The biggest problem with this is your compositor has to be reinitialized. So you've got your GNOME shell running, your Kwin running on one GPU. Now you want to make that GPU sort of go away and have all that rendered by the other GPU. So you have to literally just restart the compositor pretty much. Apple sort of seem to be a lot more subtle. They seem to hide it inside their OpenGL layer somehow, or at least because they do it so smooth. I have no idea how else they could do it.
Yes, hidden in GL.
Yeah, it's hidden in their GL layer.
How do you deal with GL client's application with the fact that basically the capabilities are changed?
If there's a GL client application running, you don't switch. That's what everyone else does. The only problem is the compositor. Everything else is if there's something running, you don't switch.
So even on a Mac?
Yeah, they won't switch. Well, generally what will happen if there's a GL application running, it'll be running on the other GPU anyway. So they also limit their capabilities to be pretty much the same on both GPUs, which we won't do either.
When
So.
you start having your GUI framework, so GTK or something, starting to use GL for widgets.
Yeah, we're proposing extensions that will hopefully at least alleviate that problem. And apps we can say. Yeah, but there's a basic problem like if you're running an OpenGL application and you want to switch, and the new GL driver has got more capabilities or less capabilities. How do you resynchronize your view of the world? From a compositor point of view, you can control it a bit. You can say the compositor is only going to use this set of features, and then it makes it easier. But you still have to do a lot of work. You have to plumb this all through X Windows kernel, Mesa, compositing library, whatever the compositing library is built on top of. There's a lot of layers. There's a GL extension called A or B robustness, which is designed for phones and stuff to say, hey, you just lost your context. Restart, redraw everything, do it all from scratch. We're going to hope to leverage that, but we haven't got actually support for that yet. It's more meant for things like WebGL, but where you've got a rogue app that does something and stops your GPU, you could blow away the rogue app. But it's actually quite suitable for this as well. And then there's even the more future. This is sort of like where we'd like to end up, but again, it's a bit of work. The idea is that there's a thing called Shatter, which has been going around for years. I think it's been talked about more than it's been implemented. The idea is that you would, I have a better slide on it later, but yeah, you would break up the rendering of the whole screen between all the GPUs. So it's more for the case where you've got multiple graphics cards in your desktop system, or you've got something like that. You can then break it up. NVIDIA kind of support this with Xenorama, but it's still very messy. And Xenorama limits what you can do. You can't do any sort of 3D applications with Xenorama. It turns off direct rendering. So the idea behind this is that it would allow us to try and solve that problem with compositing and Xenorama in the future by just, instead of having the protocols, this magic protocol screen doing the multiplexing, you would do it at the bottom of the protocol screen and then send it to each GPU driver what it needs to draw and then what it needs to display, and lots of shared buffers would happen. So these are the two sort of features that are to be done, or on my list. So how do we get to this magical, wonderful future? So just a quick overview. The X server has a set of objects. This is probably a little subset, but these are the ones I have to care about. You realize there's pix maps, graphs, context, pictures, windows, and color maps, but when you actually look at what you need to do rendering, on the GPU, you really only need the pix maps, the context, and the pictures. You don't really need the whole concept of a window is an abstraction that the GPU doesn't need to know about. From the GPU point of view, it's just a pix map with a clipping, this is your space you're allowed to draw in, or maybe a funny shape, or maybe multiple clips, but generally, yeah, that's all it is. So this was the first realization, well, maybe I can simplify things, at least in the driver side, by getting rid of some of these things and just, you then have I've got a big pix map and then I have little pix maps in each driver, so you don't have to worry about if your window goes across them, you can figure it all out in this layer. So how does this going to work? This is sort of how currently X works. The green line is generally for what you would consider protocol things. So protocol gets decoded, it goes through the damage layer to see if it's going to damage anything, the rendering is going to happen. It goes into the acceleration architecture, and the acceleration architecture can use the software renderer at the bottom optionally. The red line sort of is, what happens often is some rendering operation will then cause it to do other rendering operations. So you'll need to do a temporary rendering operation to complete the original one. And in that case, either the acceleration architecture or the frame buffer, the FB renderer, will create another object, and then that will go back through the top again and down through damage and stuff will happen. So you have this sort of concept of objects that come in from outside the server and then objects that are internal to the server. So green lines are objects from outside the server and red lines are objects that are internal to the server. Quad damage. I tried to get the sound to play, but I couldn't find it. So how do we fix this so we can do protocol and GPU objects? Well, it's a computer's problem, so we just stick another layer of abstraction in. So I introduced this thing called the impedance layer. And basically the impedance layer's job in this case is to try and separate those worlds. And you'll notice quad damage isn't really, there's two damages. The problem is you still have to track damage for protocol objects, and you need to track that above the impedance layer because there's certain protocol things that happen that need to track damage. But you also need to track damage for the internal GPU objects. So you need to then have damage in two places, it actually works, but it's kind of a bit overhead I didn't like. But this is currently the way it's sort of looking. But the big question is, what the hell is in this impedance layer? Who knows? So impedance layer. I came up with two answers for this. I'm going to go with the one I came up with first. So approach one was, well, we have two worlds. We've got protocol object world, GPU object world. The only place they ever meet is in the middle in the impedance layer. There's no sneakiness. There's a nice picture of it. So green lines and red lines are only internal in the GPU objects. Those green lines should probably be red lines. I screwed up. Bad picture. Now I realize. But or did I reverse it? Yeah. Problem with this is the impedance layer is very complex. You have to take protocol objects and take a rendering operation. So if you've got a rendering operation that's on a window in the middle of a big pix map that's this size, you need to translate the rendering to the right place. You need to change the values you've received from the protocol. Xenorama does this. The FB layer sort of does it at the end.
Why don't you just put an offset of the graphics in the graphics context on the other side? Offset.
It's not enough. It's not just that problem. That's just a simple explanation of one of the problems you come across. There's a lot of them. You want to look at Xenorama and then go, ooh, it's messy. And the other problem, you have to generate a lot of clips as well. You have to change the composite clip. And there's a lot of crappy stuff. So the other problem you have is, where was I? So yeah, you need to convert these objects. It's quite messy. There was a layer called a composite wrapper that used to be in the server because we didn't want to put composite things into rendering into the XAA layer. It's sort of like that and the Xenorama layer merged, messed around with. It got very messy. And the problem we have at the server at the moment is not a huge amount of development bandwidth community. In fact, Keith is the only person I think that could probably review this, and maybe Eric. It's like, it was messy, and it was like 2,000 lines of code messy. So I pretty much wrote this a couple of times now and sort of gotten, that works, but how the hell is anyone ever going to figure out, validate it or merge it? We also don't really have a great rendering test suite, so I probably will have to make a divergence to actually writing a rendering test suite so I can actually test.
Which would be a good idea.
Yes, would be a good idea anyway, but yeah, I need to make that's a long diversion. I'm not sure. The other option was, well, we could just sort of make the impedance layer a bit more permeable. Let's stuff through it. So the GPU layers could actually parse either protocol objects or GPU objects, and it would deal with it down at the bottom. So when you finally actually had to draw to it, the logic that's already there would just work, and it actually does just work. So hence this picture. I get these pictures running around. Yeah, I got the pictures backwards. I did, yes. Moved the slides wrong. Sorry. So, I'm not sure how to go back. So this picture is actually beautiful. So in this case, you let the protocol objects go into the layers. You don't have a magic translation layer that does crazy stuff. You just literally do an impedance layer that passes stuff from here to here. Runs into a small problem. The current way to get your the screen object, which is it's either your protocol screen or your GPU driver information. The current way to get that is by dereferencing the PIX map or the window, generally. But when your PIX map or window is no longer guaranteed to be from you, that doesn't work anymore, because you dereference, the GPU wants the GPU screen, it doesn't want the protocol screen. So you dereference this object and it's like, oh crap, wrong screen. What do? Fall over. So the problem is everywhere in the server, and all the drivers do it that way. Everyone uses this pointer. The two paths we have for rendering, the GC path and the core rendering path, and the render path. The GC path has a screen that you can use for this. There's actually another screen that you can abuse. The picture structure doesn't have one, but you can add one there, and there's a few other APIs you need to change to do this. It's a lot more reviewable. It's a lot less flexible in long term because of the last problem. Shatter. To get to shatter, the first approach is the only way it can work. But so you essentially would end up doing the second approach because it's easier now, and then throwing it all away because you need to do this to get shatter. So I'm currently in a state of flux. I've actually implemented, I think, 3 different ways so far. These are only 2 that worked. But yeah, it's mostly a plan of review and onwards movement. So yeah, I'll probably start cleaning these up and send them on. So it's pretty much me finished. If anyone has any questions, not Wayland questions, that's for Daniel after this.
Who's first?
They only had Wayland questions.
Since there's a big rush, I'll ask a question. How's everything going with dynamic power management for dual GPUs?
Oh yeah, sorry, yeah, that's because I didn't touch on that in this because it was mainly the X server stuff. But yeah, I have been working on another project. Silly me, too many projects. But yeah, so there's 2 cases of dynamic power management. There's I'm using the GPU and I want it to slow down to save power, and there's the 2 GPU laptop. What the hell is that GPU doing on and eating all my power? The first case, let's start with Intel have pretty much standard, it works fairly well. AMD, hopefully soon, will release the code to do dynamic power management on all of their latest chips. It's been written a few times and it's been legally reviewed a few times, but I think they're finally getting it in a good place now. NVIDIA, from the Nouveau point of view, the Nouveau guys have a long, very large mountain to climb up because it's impossible. Reclocking memory is arcane, and even after they talked to guys in NVIDIA who said, oh yeah, we just get a special sheet of paper from the guys who designed the hardware with just put these numbers in these places and it will work. So it's like, okay, so we're just going to copy them. So the latest chips, I think Ben Skeggs, the Nouveau guy, has just started on that about 2 weeks ago. He works in the office with me, and about 2 weeks ago he just sat down and started trying to figure this out. He literally is changing 1 bit in the BIOS table, booting the machine, changing 1 bit in the BIOS table, booting the machine, just collecting huge amounts of data. Afterwards, he has to go back and work out what the hell the data means. So he's probably never going to work out what the hell the data means. He just has to work out how to make it go from here to here and not crash your machine. So his main driver is he wants to play StarCraft with Nouveau, so hopefully that works out for him. It's not Red Hat that are making him do this, he just wants to play StarCraft. So. Then the other problem case is, what the hell do I do with my secondary graphics card? Because it's not useful and it's just burning crap. I actually have written patches to use the kernel's dynamic power management stuff, the runtime power management stuff that's in the kernel now, for both Nouveau and ATI. It works, but I have to clean it up. On ATI it's working fine. Like I have a laptop that, certain problems, like if you're using the kernel's power auto suspend functionality is great, but you run LSPCI, it has to wake up your graphics card, because it's essentially the graphics card go into, if anyone knows power management, it goes into D3 cold, which is, it's not there at all. So to do LSPCI, you've got to wake it back up. To wake it back up, you've got to post it. So you've got to run the whole BIOS. So you're running LSPCI and then it goes back to sleep, and then you run LSPCI again, it takes a noticeable amount of time because the card's going to sleep. But it does work. The biggest bits missing are, the other problem with a lot of these multiple graphics is HDMI audio devices are also on these graphics cards. And they're handled by a completely different part of the kernel. And I need to figure out how to get the power management domains to deal with that. And currently with one machine I have, I can't suspend and resume normally when I have this enabled. I don't know why, I haven't had time. It's one of these machines that's just undebuggable. Every time you try to plug in a debug cable, it craps out. So it's like on my list to figure out how to debug that. So I'm hoping to get those in the kernel. I hope to get them in for 3.7, but at the rate we're going, it'll probably be 3.9, 3.10, whatever we call the number after 3.9. But they save about, I think I was saying like 7 or 8 watts. So it's not unsubstantial.
Is fixing the LSPCI problem significant? We could do some interesting things with caching at least the first 40 bytes of config space.
Well, I don't think it's a problem. Like it handles it. The auto suspend code handles waking it up fine. It's just whether somebody else thinks it's a problem when they have the LSPCI lock. The X server currently on startup deals with it. It goes, hey, we'll wake it up in the right order and stuff. So everything works. It's just certain things you think, well, oh, this should work faster now. Booting a card takes a while.
Clearly, I'm not going to ever regret buying my Optimus laptop, but with your latest work, does it mean that as long as I don't care about the fact that the NVIDIA GPU doesn't ever turn off, you can actually display stuff through the hardwired HDMI port now?
Yeah, with Floor 18, with all the updates installed, it should work.
Thank you very much.
So we have time for a couple more questions if there are any. Well, in that case, let's thank Dave again once more.